Welcome back, guys. We'll continue. Okay, welcome back, guys. Welcome back. We'll continue from we left off, where we're doing the increasing and the decreasing of our graph, our interpretation of our graphs. They gave us this function. We haven't learned how to grow the graphs, so we still have to grow the graph, but we're just interpreting now the graph in terms of increasing and decreasing of our graphs. So continuing from the previous video, now let's do examples in terms of how do we see a graph with increasing and decreasing. So the graph of 2x cubed minus 3x squared minus 12x is shown alongside, determined by calculating whether f, which is this function f, it's increasing or decreasing at those particular points that they gave us here. So let's find the solutions at point where our x is equal to -2. How do we determine a graph where it's increasing or decreasing? First, by doing the derivative. We derive first, and then we see where does the graph increases or decreases. But let's take a derivative of our function. Deriving this function is just going to be 6x squared minus 6x minus 12. This is our derivative, and then now we are checking it from where x is equal to -2. So we're just going to substitute our -2, 6 into -2 squared minus 6 -2 minus 12. Our answer is 24. So our f prime, where it's -2, is greater, mkhulu kunobani, kuno 0. So if our f prime of -2 is greater than 0, what does this mean? Function yethu inkulu kuno 0, meaning our function is increasing. At x is equal to -2. I hope we do get this one. Function yethu here, our x prime of -2 is greater, mkhulu kunobani, kuno 0. So our f is increasing. F is increasing. It's not f prime that is increasing, but f, which is increasing or decreasing, is determined by f prime of x. Let's get B from our derivative where x is equal to 0. So we're gonna substitute from there. Substituting 0, 6 into 0 squared minus 6 into 0 minus 12, just gonna get -12. So our f prime with 0, it's less than now. This thing is less than what? 0. It's negative. 0 mkhulu kuno -12, so it's less than bani, 0. So if it's our f prime, it's less than 0. What does that mean? It's meaning our f, our f is decreasing. At x is equal to 0. At x is equal to 0. Ubano decreasayo, it's a f function, but it's determined by what? By what derivative of that particular x value. I hope we do get that one. And then let's move on to another one, which is uc batini, where x is -1. We substitute our -1 in our f prime. It's 6 into negative 1 squared minus 6 into negative 1 minus 12. Here when you punch your calculator, you'll see you're gonna get 0. I hope you still remember. If now the f prime of negative 1 or the f prime of whatever specific x value is equal to 0, this means your f prime is there here in a stationary point where your gradient here is 0. So this is where your stationary point is at. So here, from here, you still remember that f has a stationary point at x is equal to negative 1, because our gradient here, our f prime into negative 1 ilingana nobani no 0. So that means we have a stationary point. What does stationary point mean? Meaning that f is increasing, it's increasing before the stationary point meaning from here going this direction it's increasing, and then decreasing, say decreaser, and then decreasing after what our stationary point, So from here now going this side yenzani ya decreaser. So therefore what does that mean? Meaning that f is both increasing and decreasing at x is equal to negative 1. At x is equal to negative 1, both x and at f is both increasing and decreasing at x is equal to negative 1, because before it's going there increasing, then after it decreasing. Then let's find d here, where x is equal to 3, substituting in our f prime. So it's gonna be 6 into 3 squared minus 6 into 3 and minus 12. As your calculator here, you will get what? 24. Getting the 24 here, f prime of 3, it's greater than 0. Mkhulu kunobani no 0. If mkhulu no 0, what does this mean? Meaning our f is increasing at x is equal to 3. It's f that is increasing, it's not f prime of x. It's not f prime that is increasing, it's f that is increasing. I hope you get that one. I hope you do get it one. And then if f prime, now okay, let's do e, the last one. If x now is equal to 2, so let's put f prime of 2, where 6 into 2 squared minus 6 into 2, then minus 12. This here we get what? 0. As you can see, if you calculate out, you get 0, which is this one, where x is equal to which is this one where x is equal to 2. This is where you get our another stationary point. So our gradient here ubani 0. What does this mean? It's meaning that our f has a stationary point at x is equal to 2, and also our f is now from this side going here before reaching here, it's decreasing. So f is decreasing before the stationary point. Just gonna say st sp, which is stationary point, and it's increasing now after our stationary point, reaching it 2 now. After it going up, now it's increasing. So our f is both increasing and decreasing at x is equal to 2. I hope you get that one. I hope you get that interpretation of the graph. Thank you. Okay guys, now we'll be looking where we find a stationary point. I hope now we know what is the stationary point. A stationary point, it's where our graph, or it's where the point here, our gradient at the stationary point is it's 0. When it's our gradient, meaning the f prime of x, meaning the derivative of a particular point of x of a, whatever x value that it's there, is equal to 0. Our gradient there is equal to 0. That's where our stationary point. So now we'll calculate our stationary point, or calculate the coordinate of this stationary point. How do we calculate the coordinate of a stationary point? They have given us this function, and then they say we must calculate a coordinate of a stationary point. How do we calculate the coordinate of a stationary point? Remember, the stationary point, it's where the gradient is 0, it's where our derivative is 0. So we must find the first derivative of our function deriving this. So it's going to be negative 3 x squared plus 12x minus 9. And now we know that the stationary point is where our gradient is 0, meaning our f prime of x is equal to 0 at the stationary point. So we say 0 is equal to negative 3x squared plus 12x minus 9. Then we need to calculate our stationary point. We can still divide by 3 here, divide by 3, negative 3, negative and negative, it's positive, positive and negative, it's negative. 12 divided by 3 with 4x, and then 9 divided by 3 with 3, negative divided by negative, it's positive 3. Factorizing these two factors, I hope you know how to Factorize. If you don't know how to factorize, you can use the quadratic formula. It's still applicable, guys. If you don't know how to factorize, make sure you use your quadratic formula. And then from this, x is equal to 1, and or x is equal to 3. X is equal to 1, and also x is equal to 3 from our graph. I hope it makes sense. Now if we're looking at our graph, now we need to find our y. They say coordinate, so we need to find y. How do we calculate y? I hope you still remember there. We take our x's there, we substituted it at the original equation, at this equation. That's where we calculate our y coordinate. We don't substitute it on the derivative, but we substitute it here. I hope you still understand that one. So at x is equal to 1, we must find our y. So it's equal to 1. Squared minus 9 into 1 and plus 3 is equal to negative negative 1. So our point here is 1 maps to negative 1. When we substitute here with 3 again, squared, you can punch your calculator to confirm that it's 1. It's negative 1, guys, here. And then 3 plus 6 into 3 squared, and then minus 9 into 3 plus 3. Here, what do we get? We get 3 also. So our point here, 3 with 3. So our stationary point, it's where 1 is equal to, it's mapped to negative 1. Here 3 is mapped to 3. This is our stationary point. This is how we find our stationary point. It's very important. Stationary point is where our gradient is 0. Here our gradient is 0. Here our gradient is 0. How do we find the gradient? We derive our original equation, our function. I hope it's very important. You don't misinterpret or confuse yourself now with why now the derivative is 0, because we said the derivative is equal to the gradient. Yes, the gradient here at this specific point, our gradient here is 0. Also our gradient at this specific point here, it's what? It's 0. That's why we calculate our stationary point like this. I hope you do understand that part. Thank you so much. Okay, guys, our second part of the question here, which is B, where we need to calculate to find the values of x if f, which is our function f, first it's increasing. Now we need to find where a graph is now, what's a graph to increase a p, and also a graph to decrease a p. So let's find the first one also. Now B, number 1, where a graph to it's increasing. Now increase a graph from this point, because from here going down it's decreasing before it reaches point. But now when it reaches point, going up, yeah, increase. So where does your graph increase? Increase from this point, going here, going here, until it reaches this stage. So this is where our graph is increasing, because now going to this point our graph is decreasing also coming from here to here, our graph is decreasing, but where it's increasing, it's from here to here. So now the values of x, starting from what is our x here, our x is 1, so from 1 into x, and then it's end where it's end at 3. From 1 going this side, we are going to our values of x where they are bigger than 1, meaning our 1 is less. So our 1 is less than what? The values of x. Then from this side, which is 3, with 3 going to this side, our 3 is bigger than the numbers of this side where the x, these values of x going from this side. U3 wethu ungakanani? Mkhulu. So our values of x from this side mangakanani? Mancane. So this is why we are saying like this. Do we include them? Yes, we include. So we're gonna just write less than, equal to, or greater than or equal to, or 3. That's where it's starts from here, the increasing. That's why we include them. Inclusion meaning we write this thing here, which is means we do include 1 and also we do include 3. That's where our graph is increasing. Number 2, where it's decreasing. Decrease where now? Decrease where now? From here, coming here, coming here, coming here, coming here, coming here, until this point. Coming here, coming here, coming here, coming here, until this x. So our values of x, no bani, no 1. So now my question is, lama u1 nang la siyambona u1, lama values angapha u-x angakanani kuno 1. These values, no 1 la, and we also have these values here of x which are from ugly side elingapha, from this side angakanani from u1. U1 ingakanani? Mukhulu, meaning these values of x from this side are less than ubani? U1, but we do include ubani? 1. Also decrease will be put also from this side. So we are decreasing from this side, decreasing from this side, decreasing from this side. So x and 3 decreasing from, starting from 3, now going to the values of x which are from this side. From here with 3 going to this side. So our values are x angakanani kuno 3, u3 nangla, and then going to this side 3, 4, 5, 6, 7, 8 ungakanani ku 3. 3 is less, meaning 3 is less than x, or greater or equals to it, because we include the decreasing part start from 3. So we do include 3, and also the decreasing part here ends at at 1. That's why we do also include 1. So here is decreasing. I hope you do understand that one. Very, very important, these types of questions, because they are not easy marks, but you need to understand them because they are very vital. It determines the level that you want to get in mathematics. So hopefully our aim here is to get a best level as we can, level 5, 6, 7. That is our target here. Hope you understand it. Thank you so much.